Hi everyone, in this video we are going to talk about the access modifiers. What are access modifiers? They are keywords that are used to identify the availability scope of a certain code. We can use them on classes, methods, types, properties, and so forth. In the program.cs file of our MyRobot project, the keyword internal in front of the class program is an access modifier. It defines that the program class is available anywhere inside the MyRobot.exe file. In fact, there are 6 access modifiers in C#. But before we go through those, let's talk about what on earth we need to use access modifier. If you Google it on the web, you might get something like access modifiers are used to implement encapsulation of object-oriented programming. Access modifiers allow you to define who does or who doesn't have access to certain features. Well, that's correct, but not easy to understand. In my own words, I'll say that access modifiers are all about sharing. Imagine your program is a public park. The open area of the park should be available to everyone, but the security office of the park should be employees only. You won't let anybody access the security office without proper permission. And the personal belongings of an employee who works in that office should be absolutely private to that employee only. It's the same concept of access modifiers. The 6 access modifiers include public, protected internal, protected, internal, private protected, and private. Each access modifier defines a different scope of part of your code's access level. I won't read through all these definitions for you. You can bookmark this page and read them later. I have prepared a comparison table for better understanding. This table demonstrated here tells the same story as the last page, but I believe it's much easier to understand. You can see from here, if you want to keep the accessibility of your code only inside your program, no matter it's an exe or a DLL file, then using internal, private protected, or private will be enough. But if by any chance that you want the code not only can be accessed inside the current assembly, but also could be accessible by programs that are outside the current assembly, then you must use either public, protected internal, or protected. It makes more sense now, don't we? By the way, I marked public, internal, and private in yellow. That's due to, from my experience, they are the most frequently used access modifiers. You can omit the access modifier in your code. If there is no access modifier declared for a class or method or type, then C# will use the default value instead. In our example, if you remove the keyword internal away from the class program, it still works. And the default access level for the program class is still internal, because internal is the default access level for classes that are declared directly in a namespace. Then can we change it to public? Of course we can. You see, there is no red wavy underline. That means we can declare class program as a public class. Then can we change it to private? Let's try it. Uh-oh, the red wavy underline occurs. Let's move the mouse over it to see what happens. It says elements defined in the namespace cannot be explicitly declared as private, protected, protected internal or private protected. So we can only use internal or public here. Okay, now let's create two more classes beneath the program class. The first one will be class robot. Actually, we really need a class robot in the future. Visual Studio's IntelliCode already prompts us to create a string type property called name, and its accessibility level is public. Let's press the tab key to establish setting, because we are gonna need a property called name after all. And the second one will be class robot2, but inherits from class robot. The colon robot here means inherits from robot. Robot2 won't do anything. It's gonna share robot's name property. Now what's the access level of class robot? Since I didn't declare any access modifier, by default it should be internal. Then what will be the access level of class robot2? Of course it's internal. What if we change robot2's access level to public? The red wavy underline again. Why? Let's look at the error dialog. It says inconsistent accessibility. Base class robot is less accessible than class robot2 because robot is internal, whereas robot2 is public, which means robot2's access level can only be internal. Okay, let's try to call these two classes from the main method. I'm going to insert the new code at the beginning of the main method. First, we need to declare a new instance of the robot class and assign it to a variable with the type of robot. Robot underscore lowercase robot1 equals new uppercase robot semicolon. Then underscore robot1 dot name equals double quote John semicolon. Console.writeLine double quote underscore robot1 dot name is plus underscore robot1 the name semicolon. Second, we declare another variable with the type of robot2. Underscore robot2 equal new robot2. This time we don't assign value to robot2. We display its name value directly. Robot2.name semicolon. Okay, now run it. You see, underscore robot1.name is John, but underscore robot2.name is nothing. Why is that? Even though robot2 is inherited from robot class, they are now like a father and son relationship. We gave the father underscore robot1 the name John, but we didn't give the son's name to robot2. Let's try again. Let's assign underscore robot2.name with the string Michael. Okay, run it again. You see, robot 1 is John, robot 2 is Michael. Now you might be wondering, why do we have to use the new keyword to create a new instance inside the main method? Why can't we just use their name property directly like the way we call the greeting method and a conversation method? Well, that's due to this keyword static. Static is also a modifier, but it's a special modifier. It could make a class, a method, or a tab globally available. There will be only one copy of that class, method, or type in the memory. So which means static items cannot be used with the new keyword to declare a new instance of that item. Let's make a small change to our robot class. Let's add a static keyword to its name property. Wow! Now there are lots of errors in the main method. That's because we just changed robot's name property to static. Like I mentioned earlier, static objects are globally available to everyone and there's only one copy allowed in the program. So we cannot use static object by creating a new instance. We access them directly. Here's what we are gonna do. Select those two lines of code and press 3-key combination Ctrl+K+C to comment them out. Type uppercase robot.name equals John, then change robot 1 to robot, and then do the same thing to those two lines of robot 2. Change underscore robot 2 to robot 2. But we don't assign Michael as robot 2's name. Let's see what will happen. You see, robot.name is John, robot2.name is also John. That's because both name properties point to the same one, so they are both John. What will happen if we assign Michael to robot 2? Let's try it. We will display robot's name after we change robot 2 to Michael. You see, after we assigned Michael to robot 2, robot's name was changed to Michael as well. That's how static works. Then how does private work? Let's create a new property called gender in robot class and make it a private string property. Now go back to the main method. Can we access the gender property directly? Nope, cannot see gender. How about we create a new instance? Robot underscore robot 3 equals new robot underscore robot 3 dot still no gender Because gender is private to robot class itself, it can only be accessed in robot class. Actually, the underscore response variable is also private to the main method. Only codes inside the main method can access its value. Codes outside the main method just can't see it. So, to sum up, classes declared directly within a namespace could be either public or internal. And internal is a default if no access modifier specified. Members of a class could be any of those 6 access modifiers, but private is the default if no access modifier is specified. And a derived class cannot have greater accessibility than its base class. And regarding static, is static equals public? The answer is no. Even though they both mean globally available, there will be only one copy of static members in the memory, whereas we could have multiple new instances of a public member. Public and static could be used together. Okay, how about the access scope of a namespace? A namespace access scope is always public, because a namespace is meant to be used by anyone anywhere, so it cannot be anything else other than public. Okay, that's all for this topic. Please join me in the next video. We are going to talk about variable types and the C# naming convention.